Hi all, this is Xindong Zhang. Let me introduce our work on patch recommendation. This is joint work of Alibaba Group, UT Austin, and NTU. Patch recommendation is the process of identifying errors in software systems and suggesting suitable fixes. Automated patch recommendation can significantly reduce developers' debugging efforts and costs, improve software quality and system reliability. We conducted a preliminary study of the usage scenarios of patch recommendation techniques within the company, and empirically analyzed the characteristics of the company codebase. We found multiple challenges. We need a general solution for diverse applications, and test cases and patch labels are insufficient. And our technique is required to be highly responsive and have low false positive rate for practical usage. We propose our solution Prefix, a pragmatic approach targeting large-scale industrial codebase and making recommendations based on previously observed debugging activities. It automatically mines bug and fix templates from historical code changes using generic features, which doesn't rely on patch labels and can handle diverse applications. Our solution is independent of test cases, and we use developers' feedback to validate and improve. As for practical requirements, we can scan and recommend the patches within milliseconds. False positive rate is 22%, and we are improving it by developers' feedbacks. Here is the specific introduction to Prefix. We extracted sample benchmark set which includes over 10,000 projects, spanning over 15 million commits and 30 million files. For the offline patch discovery, it consists of three main steps. First one is defect patch pair extraction. We made use of keywords like fixed bug in commit message to extract bug-fixing commits. We observed more than 3/4 bug-fixing commits have such pattern: delete bug snippet and add patch snippet. According to it, we extracted defect patch pairs. These pairs still contain noises. Then we apply clustering techniques to cluster similar patch behaviors. DV-scan is our choice for clustering, and the combination of leave-stand distance and Jacquard distance is applied for similarity comparison. For sake of efficiency, we used MapReduce and used SimHash plus KD tree to avoid most comparisons between two totally irrelevant defect patch pairs, which saved us more than 95% running time. Finally, we extracted defect patch templates from clusters. For the online part, Prefix will scan developers' code change when they commit code review. If defect templates are found, patches will be recommended on code review system. These developers will give us feedback for further improvement. You might be curious about what kind of patches that our solution clustered. I randomly sampled 50 patches found by Prefix and made a classification on them. They can be mainly divided by three classes. Most of them are API modification, like the modification, addition, or deletion of the parameters. Validation check accounts for 26%. It includes non-pointer exception check and boundary check. API wrap class is out of our expectation. This kind of patch recommends developers to use already existed utility functions instead of implementing it again to avoid unexpected defects, which indirectly improves the code quality. Finally, we talk about results. The false positive rate is 22%, and it is supposed to be reduced gradually. We interviewed some developers and received many positive feedbacks. The offline patch discovery part costs 5 hours or so, and it can do patch recommendation within milliseconds. prefix has been deployed on code review system in Alibaba for 1 year so far. Thanks for your attention.